Fine, let's start our session, today's session with the discussion of past paper MCQs from electronic configuration. Okay, so as you can see, we have marked the questions which we can try with what we have learned so far. Right, so let's get started. Okay, so first let's focus on the question from year 1980. Relatively older questions, but must be quick practice. So let's see. How many of you attempted these questions? Can I see a raise of hands? Good. Right then, first part. The electronic configuration of an atom with atomic number 35 can be classified as. So now I've told you before, you have to have your periodic tables ready whenever you do chemistry questions. So which atom has an atomic number of 35 in the periodic table? It's obviously bromine, right? Bromine. So when you consider the atomic number of bromine, bromine is 35, right? So they're asking electronic configuration of an atom. Okay, the last part, bromine means you can write up to 35. Now you can write up to argon, which is 20. Yeah, 20, and 4s, 4s2 22, no, 18, 20, then 30, 3d10, and then after that 4p5. So it will finish at 4p5. Fluorine, chlorine, bromine, they all finish at p5. Therefore, what is the final answer, people? And we know we can rewrite it properly. 35 bromine should be rewritten until argon, and then 3d10, 4s2, 4p5. Okay, so 4s2, 4p5 is the answer. Fourth one. Right. The element with the atomic number 33 can be specified as 33 is arsenic. Right? 33 is arsenic. So arsenic 33, according to periodic table, we will identify that goes like this until argon, then that is 18, 20, 30, 33. So if you rewrite it, it will be until argon 3d10, 4s2, 4p3, no people, 4p3, because you just have to reduce 2 electrons from this. It's 2p3, easy. That is the third one. This we don't know. And I think now we can discuss which of the following is not isogonal. We can't, because we have to know the structure of these things. We don't know the structures of these things yet, so we have to wait until we study how to draw their structures. Okay, right. I think you might have issues in identifying the structure. Plus, yeah. But just for the sake of trying it out, can you guess it, people? I hope you can remember these kind of structures. Now, carbon dioxide structure looks like this. You don't know this yet, huh? We'll learn about this. Oxygen structure looks like this. N2 structure, it looks like this. Cn minus. NO plus, it looks like this. So which one do you think is not isoelectronic? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, this one is not isoelectronic, no, people? This one, second one is not isoelectronic, no? O2, exactly, yes, good. But the problem is you need to know their structures, otherwise you can't draw them. O2 is not isoelectronic because it has how many electrons total? 12 electrons. O2 has 12 electrons there. The others have 10 electrons. If you count the number of electrons, 1, 2, each bond has how many electrons? 2, 2, 2, 2. So 10 electrons. This has 10 electrons. This has 12 electrons. 2, 2, 2, 2, 8, 2, 10, 12. Here 10, 10, 10. So all these have 10 electrons, but you don't know how to draw these structures. We will be learning that in second unit. We are still in the first unit, people. But for you to get an idea about isoelectronic, this is it. Isoelectronic means they should have that species, both the species should have equal number of electrons, total number of electrons. You just have to count the electrons, total electrons, and see whether they both have same number of total electrons. That is what you call isoelectronic. When you compare between two, okay, like isocentric we have in O level. I don't know, if you draw two circles and if they both have the same center, they are isocentric, something like that. Oh no, they're called concentric, not isocentric, concentric. Here, if they just like that, if you have equal number of electrons, we call it isoelectronic. That is concentric, no, not isocentric. Sorry. An element M forms a static M2 plus ion. The atom M and the ion have the same what? Have the same. Now you when you want to form M2 plus ion, what do we do? What happens there? M atom turns into M2 plus ion, releasing 2 electrons. Okay, but what will not change? Let's see. Chemical properties will change for sure. Chemical properties will be completely different. Nuclear charge, what about the nuclear charge? Nuclear charge will not change. Nuclear charge means, in other words, can someone tell me another word for nuclear charge, people? Nuclear charge, it is a number of protons. Nuclear charge has another word. It is a number of protons. Now, when you take magnesium and, for example, when you take magnesium and magnesium 2 plus, okay, magnesium turns into magnesium 2 plus, things like that, will you? Right here. If you take magnesium, it turns to magnesium 2 plus while releasing 2 electrons. No? So, if you consider the number of protons, it has 12 protons. Electrons, 12 electrons, but here 10 electrons. No? Neutrons, 12 neutrons, 12 neutrons. Got it? So magnesium is 12 and 24. Therefore, when you remove electrons, you never remove protons from magnesium, and protons, for number of protons, an alternative term we give is nuclear charge. Okay. Right, all the others will differ. I thought you will be able to decide that based on just this. Now 2, 3, 4, 5, we haven't learned enough for you to decide about them, but we have learned enough to decide about the first one. Okay, right, then let's move on. The electronic configuration of an atom X is given like this. It's actually arsenic, no people? Here 4p3, it's arsenic. The chemistry of X is therefore likely to be similar to that of who? Any guesses? Who is that? It will be similar to who? It will be similar to, okay, I have 3 answers, right? It will be similar to nitrogen, people. Why do you all say 5? Why do you all say 5? No, zinc. Why is that zinc? I didn't get, why is that? Close, no. That has nothing to do with it. Close to 30, no. You have to decide it based on the group number. I think that also you will understand more once we study about periodic table today. Now, if you take nitrogen, look at nitrogen. Huh? Nitrogen's electronic configuration ends where? Nitrogen is 7. It is 1s2, 1s2, 2s2, 2p3. Phosphorus 15, 1s2, 2s2, 2p6, 3s2, 3p3. Likewise, arsenic, which is 33, you write it until argon 4s2, 3d10 or 3d10, 4s2, 4p3. So S2, they all their electronic configuration ends in S2, NS2, and P3, NS2, NP3. They all have similar properties. If you take the periodic table, these three will be in the same period. Now if you take periodic table, when I say periodic table, you know, right? Carbon, silicon, germanium, tin, lead, and here nitrogen, phosphorus, arsenic, antimony, bismuth. It goes like that. And then you have oxygen, sulfur, selenium, tellurium, polonium, and then you have fluorine, chlorine, bromine, iodine. So whichever elements are in the same group, they will have similar properties. It's not about the atomic number being close to that. No, completely wrong. It's about the period. Okay, can I see a raise of hands? Sorry, it's not about the period, it's about the group. So can I see raise of hands if you understood that? So in future, look for the last electronic configuration. If the final electronic configurations are similar, that means their properties must be similar. Okay, let's be careful. Right, next one. The fluoride ion has the same electronic structure as, okay, what about that? Chloride ion. So when you fluoride ion, when you take fluoride ion, the fluoride ion means F minus, no? Right, F minus. F minus is 1s2, 2s2, 2p6, remember. 2p6. So chloride ion, Cl minus, that is 1s2, 2s2, 2p6, 3s2, 3p6. So it's similar to argon. Oxygen atom, O. O is 8, right? A. So that is 1s2, 2s2, 2p4. No. So first four, not possible. O2 minus ion, 1s2, 2s2, 2p6. Neon, 1s2, 2s2, 2p6. Yes. So fluoride is isoelectronic with oxide and neon. We did it last week. I think it should be in the next page. It is C and D, both. C and D. Can you remember the combinations? If they give you A, B, C, D type question, if C and D are correct, what should be your answer, people? C and D are correct, A and B are incorrect. What should be your answer? Our answer should be what? Third one, isn't it? Third one. Third. C and D are correct, it's the third answer. If A, B correct, first answer. B, C correct, second answer. C, D correct, third answer. A and D correct, fourth answer. Any other options, fifth answer. Okay, so this is how these questions go. We have tried 5 now, and this is how it is. Certain parts you will get understand more once we cover more, but right, majority of them you could do. Then we'll move on to the next part. 7th we couldn't do, so we'll skip it. 8th, 9th, 10th and all we can do right now. Okay, so let's focus on these. What does the 8th one say? Hold on, we have space for the questions. You should have the periodic table with you, people, otherwise it will be like difficult, impossible literally to do these questions. Right, the element that shows the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Who is that? It's pretty straightforward, no, people? You just have to count the number of electrons. Potassium? No, my god, not potassium. Copper. Yes, sorry, if the addition is 29, no? There are 29 electrons in total. We have to check for the 29th element. Should be copper. Sorry, copper only ends in 4s1, 3d10. That's very straightforward, no? The electronic configuration of atomic number 34. 34 means what is it going to be, people? That also should not be, they had asked about 33, they asked about 35. Now 34, it should be selenium. Selenium has an electronic configuration of 4s2, 34. This one. Third one, sorry, second one is the answer. Because if you write the electronic configuration of selenium, how it ends, now they're asking selenium is 34. In the periodic table you must be able to identify that. Until argon it is 18. 20, 20, 30, 34. So I have told you we don't write it like this, the final answer. Final answer we have to change it. Selenium 34 until argon, then you have 3d10 must be written first. See here like this. 3d10 must be written first and then 4s2, 4p4. So see how it finishes. D10, S2, P4. Zinc 2 plus ion is isoelectronic with same number. Oh, okay, cool. Zinc 2 plus will be isoelectronic with who, people? My god. Copper 2 plus. Wrong, no? Copper 2 plus? No. I'll just write the electronic configuration of each of those ions. The copper 2 plus's electronic configuration goes like this. Argon 4s0 3d9. When you take zinc 2 plus, its electronic configuration goes like until argon 4s0 3d10. Correct? 4s0 3d10. Nickel obviously not, because until argon, nickel fine, no? Nickel 4s2 3d8. Isoelectronic means equal number of electrons it should have, equal number of electrons. I think it's nickel. Yes. So we have to count the number of electrons. Zinc 2 plus, it's going to have 28 electrons, remember. Zinc 2 plus is going to have 28 electrons. Copper 2 plus is going to have how many electrons? 27 electrons. From 29 we have removed 2. Nickel itself 28 electrons. Arsenic 3 plus will have 30 electrons, because arsenic is 33. Cobalt has 27 electrons. Selenium 4 plus has how many electrons, someone? Again 30 electrons. So selenium 4 plus and arsenic 3 plus have similar isoelectronic with zinc, not zinc 2 plus. Not zinc 2 plus. Okay, I think this is the easiest method. Count the number of electrons. Just count the number of electrons and see who has equal number of electrons to identify isoelectronic species. Second one. Okay. Then O2 minus ion is isoelectronic with N3 minus. O2 minus ion is isoelectronic with N2 minus, right? Let's compare that quickly. O2 minus has how many electrons, people? O2 minus has 10 electrons. S2 minus has 18 electrons. N3 minus has 10 electrons. Lithium plus has 2 electrons. Beryllium 2 plus and boron 2 plus, they all have just 2 electrons. Therefore, obviously N3 minus is the answer. Correct? The element with 1 electron in the outermost energy level is who, people? Element with 1 electron in the outermost energy level. Who is that? Element with outermost energy level. 1 electron in the outermost energy level. 1 electron in the outermost energy level. Who is that? It is cesium, right, people? Cesium. It is cesium. It is cesium because cesium is 55, I think. Cesium is 55, no? Check it. Cesium should be 55. Yeah, cesium is 55. So when you say cesium, it belongs to the first group, no? Cesium. So it will have only 1 electron in the outermost shell. So cesium is 55. We can write how? We can write it until xenon. Until xenon. And then you have just 6s1. 6s1. How can chlorine be the answer? How can chlorine be the answer? Chlorine has 7 electrons in its outermost shell. No? Chlorine is 1s2, 2s2, 2p5. How do you say chlorine has 1 electron in the outermost energy level? Yeah. 7 electrons in the outermost energy level. No? Outermost energy level means the last main energy level. 7 electrons. No? I don't know how you took it as 1. It needs 1 more electron to complete the energy level. I think you got it confused with valency. They are just asking how many electrons are there in the outermost energy level. Okay. So, okay. Then what about mercury? If they ask for mercury, mercury is similar to zinc, right? Mercury is similar to zinc. Mercury will have an electronic configuration similar to who? Oh my gosh. wondering how many electrons will it have in the outer. No, carbon, okay, easy. 1s2, 2s2, 2p2 carbon. So it will have 4 electrons in the outermost energy level. Altogether we have to consider 4 electrons. Magnesium, 1s2, 2s2, 2p6, and then 3s2. So magnesium has just 2 electrons in the outermost energy level, no? It's just 1 electron. And mercury, in case in future if we are supposed to find out mercury, how do you write for mercury, people? Mercury is what? Mercury's number is 80. My god, that's too big. Mercury 80. But mercury is similar to zinc, no? So mercury's electronic configuration will surely end like this. Mercury 80, zinc ends 4s2 3d10. Cadmium should be 5s2 4d10. 5s2 4d10. So mercury should be 6s2 5d10. Likewise, 6s2. So until xenon, no, it will have an F part also, no? Yeah, okay, it will have an F part and all, it's complicated. So it will end in 6s2. It will continue like this, and it will have 5d10 6s2. That's the last. So it will have only 2 electron in its outermost energy level. 2 electrons. Anyways, 1 electron is Cc. Okay, done. And then we'll move on to the next parts. Right, we can try the questions from 13 to 16. Seems like that. Let's quickly finish them off. The electronic configuration of the element with the atomic number 48 can be specified as 48. Who is 48, people? 48, is it a special case? 48 is cadmium. No, cadmium. 48 is cadmium. Cadmium will be similar to zinc, no? Cadmium will be similar to zinc. It will until krypton. Until krypton it is 36. Until krypton, and then you have 5s2 4d10. 5s2 4d10. So you can rewrite it 48. Cadmium is 48 until krypton, and you can say 4d10 5s2. First answer, no? First answer. Yep. If we look for them in the periodic table, so if it is below zinc, it will be similar to zinc. It's easy. The electronic configuration of molybdenum is 42. The outermost electronic configuration of molybdenum 3 plus ions. Okay, now molybdenum, it's a special case, no, people? Molybdenum is below chromium in your periodic table, chromium 24, and below that only we have molybdenum, that is 42. So for this is the answer for the 14th question. For molybdenum, if you write the electronic configuration 42, how will it go? Molybdenum until argon, not argon, krypton. Until krypton we can put, and then until krypton, not until argon, until krypton, and then it is 4s2 3d4 if you just write it normally, but that is wrong. We don't have ns2 nd4 type of electronic configuration, so that should be changed to what? 4s, not 4s2, 5s2 4d4, sorry, should be 5s2 4d4 if you normally just continue to write it, but we know that is incorrect because yeah, that is incorrect. So what we need to do is we need to change it to 5s1 4d5. So molybdenum 3 plus, on the other hand, what should I do? Until krypton, I should first remove the electron from 5s1 and then remove 2 more electrons from 4d5. So it becomes 5s0 first, 5s0 and then 4d3. 5s0, 4d3. So the answer is, people, first one. I'm getting the first one. Anyone else? I hope you all got the first one. I'm getting first. It is similar to chromium 3+. They are asking for molybdenum 3+ ions. Ruksha, not molybdenum. So you have got the fifth answer. That means you have not considered for 3+. Careful. So that is going to be first one. No? First one. Read the question carefully and don't get carried away. 15th one. The number of electrons in the outermost energy level of di-positive cation, which is made from atomic number 29. Okay, who is that? Can someone tell me what is this di-positive cation which is made from atomic number 29? Can someone introduce that? Which ion is that? Oh, very good. It is copper 2+. Copper 2+. It is going to be copper 2+, people. It is going to be copper 2+. So number of electrons in the outermost shell. Now that you have to be very careful. Let's write the electronic configuration of copper 2+. We know copper, copper 29. It goes like this. 1s2, 2s2, 2p6, 3s2, 3p6. I'm writing it intense like this. It should be 3p6, 4s1, 3d10. Right, so it's 3d10, 4s1, people. It is of copper, is no? But when you take copper 2+, it is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s0, because we have to remove one electron from 4s first, the outermost main energy level, then only you have to remove from 3d. Now this has become the outermost energy level, which this, or else should it be the number of electrons in the outermost energy level? Should we take now third main energy level becomes the outermost energy level? We have 17 here, no? We have 17 electrons. So for copper, fourth main energy level is the outermost energy level, just one. But for copper 2+, I think it becomes the third main energy level. Who has the scheme for these questions? Zainab, you have the scheme. Zanir, you have checked what is the answer they have given. I think it should be 17. Check, will you? For 15th question, what answer they have given? Or else should it be 0? For copper, if you take, it is 1, because fourth main energy level is the outermost one. Okay, right, cool. Thank you. Right. So they have given the 13th one. So I think that is how we have to consider it. Because once you remove that electron from the fourth main energy level, there are only 3 main energy levels now. So the third one becomes the outermost energy level. Okay, right. The atom that consists of only one electron in the outermost energy level is, who is that, people? Oh, this is an interesting question. It should be, anyone? Chromium. It should be chromium. It should be chromium, not boron. No, wrong. Now consider these are just electronic configuration questions. On boron, it is 1s2, 2s2, 2p1. Outermost energy level means they are talking about the main energy level. 3 electrons are there for boron. Nitrogen, there are 5 electrons. 1s2, 2s2, 2p3. Chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. Chromium, remember, chromium goes like this, no, people? 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. This is chromium. So why isn't 4s0 the outermost? Because the outermost energy level, there are no electrons anymore, no, in the outermost energy level. So we don't consider that as an energy level occupying electrons. We consider only first, second, third as the energy levels now. Copper 2+ has only 3 main energy levels which occupy electrons. Since the outermost energy level does not occupy an electron, we don't consider it as an outermost energy level. But for copper, First, second, third, and fourth all are considered because the fourth main energy level is occupied by electrons. So chromium, look, it has only one electron in the outermost energy level. See, one electron. Correct. Chlorine has 7 electrons, and nitrogen has 5 electrons. Zinc, how many electrons will be there? People, zinc, anyone? Zinc, how many electrons will it have at the outermost energy levels? Can someone answer that question? Zinc will have 2. It will have 2 electrons in the outermost energy level, not 10. It will have 2 energy level, outermost main energy level, 4s2. So it will have 2 electrons. Right? Don't worry about the correctness of your answers. Make sure you learn something. You learn new things from these questions. Okay, done. Right, I'll share the screenshots so you can have a look at them again later. Good. And let's move on to the next one. 17, 18 we can't do, 19 also we can't do. We have 20 and 21 only. That's good. Right, let's finish it off quickly. 20 and 21. Now 20 and 21 you have to be a little careful. Here they are specifically mentioning about sub-energy, electrons in the last sub-energy level, I think. Look, the number of electron in the last sub-energy level of an atom of the element of atomic number 40, last sub-energy level. So first of all, we have to find out the element with atomic number 40. Who is that, people? Element with atomic number 40, check the periodic table. It should be zirconium. Wow, zirconium is atomic number 40. So is it R, right? Isn't it? Is it R? I'm wondering why they have given zirconium and all. Can't help. If they have given, we have to consider it. It is similar to titanium. It is similar to titanium. You know, zirconium is just below titanium. It is ZR. So zirconium is 40. My question is, what is the last sub-energy level? So when you write the electronic configuration state, 1s2, 2s2, 2p6, 10, 3s2, 3p6, 4s2, 20, 3d10, 30, 4p6, 36, 5s2, 38, 4d2, 40. So who is the final sub-energy level here, people? Last sub-energy level is 5s2, no? Yeah, 5s2 is the last sub-energy level because we have to. Or else 4d2. Wait, now there's a confusion here. When they mean by last sub-energy level, energy-wise 4d2 is the last one. In the order-wise 5s2. So either way, answer is going to be what then? 2, right? 2. Answer is anyway going to be 2. Sub-energy level, remember, don't forget, last sub-energy level. That's going to be 2. In main energy level also 2. Because 5s2 is the last main energy level. 5 is the last main energy level. Right. The number of electron in the first sub-energy level. I think this also should be last. This also should be last, people. 1993. Let's check the original paper. Give me a second. The original paper, probably it should be last because first sub-energy level doesn't make any sense, no? I don't have 1993. Do I have 1993? Give me a second, paper, please. 1993. Okay, I don't have. Anyone has a 1993 paper? I think probably it should be the last sub-energy level. There's no point of discussing about the first sub-energy level. Make it last sub-energy level, okay? Last sub-energy level. Because first sub-energy level for everything is 1s2, no? Let's change it to last, okay? But you have to be a little careful. Cation of sub-energy level of 3 plus 3 cation formed by the element of atomic number 42. Who is that? Who is that? Molybdenum, isn't it? Molybdenum 3 plus, exactly. It should be molybdenum 3 plus. Periodic table is there for you. to check. So molybdenum 3 plus. We have to write the electronic configuration of molybdenum 3 plus. And when you consider that, molybdenum people 42. Molybdenum until krypton, and after that you will have remember 4d5 5s1. It is similar to chromium. 4d5 5s1. That is molybdenum. Okay, so when you say molybdenum 3 plus, I think we wrote it a little while ago earlier also. It is going to be krypton what 5s0 here and 4d3. 4d3 5s0. Therefore, this is the final sub energy level now. This one, because that is the sub energy level which is occupying electrons. There is no answer called 0 here, people. So there are how many? 3 electrons, isn't it? So should be the third one. Check the scheme. They have given third one, people. Should be the third one. Someone? Yeah, okay. So cool. Right. So all you need to do is these questions are not very complicated, to be honest. All you have to do is write the electronic configuration correctly and then get the answer. Good. Then we have 25, 26 and 27. Okay, so let's see what this is about quickly. 25, 26, 27. Okay. The questions are ready for us. I think these are the last 3 questions, no? The number of electron in the last sub-energy level of the +4 cation formed from the element of atomic number 43. So they are repeating the same type of questions. They have repeated the same type of questions in the consecutive years. No, 43 means who is that, people? It's not molybdenum. Technetium. Technetium is 43. So it's technetium +4. What is the answer we are getting? Technetium is 43. Technetium, I can write it this way: in the condensed form, krypton, and it's going to be 5s2 4d5, correct? 5s2 4d5, because technetium is exactly below manganese. Now when you take when you remove 4 electrons from it, is it +4? Yeah, +4. Technetium 4 plus. I think I forgot one line. +4 cation formed from the element of number 43 is technetium 4 plus. And that is going to be until krypton. Five is 0, and here if you remove 2 electrons, it will be 4d3. You have to remove 2 electrons here, you have to remove 2 electrons here. Therefore, it is 3, right? 3 is the answer. 3 is the answer. And then assume that the element of atomic number 25 forms a gaseous ion of charge +1. Number of unpaired electrons in the ion. Okay, I think the question was missing. Then we check the original paper and develop the question. I mean, corrected the question. First of all, tell me what is the element with atomic number 25? Element of atomic number 25 is manganese, right? Manganese, yes. Manganese is the element with atomic number 25. So it forms now, that is manganese. Manganese 25, we all know the electronic configuration goes like this until argon 4s2 3d5. Wow, this is a good question, right? So if we assume that manganese can form +1, it doesn't form +1, but they're asking us to assume, then you have argon, then it becomes 4s1 3d5, not 4s2 3d4, because electron will be removed from the outermost energy level first. Now for that we have drawn these orbitals, no? We have 4s1, 3d5. So 4s will have 1 electron in it. 3d5, according to Hund's rule, will have how many electrons? 5 unpaired electrons, actually, like this. So overall, how many unpaired electrons are there, people? So a total of 6 unpaired electrons. Okay, so we have done such questions many times. This should not have been a problem for you. Fourth one is the answer. 6. But Mn plus doesn't exist in reality. Mn plus doesn't exist. Okay. 6. 27th one. Which of the following statements or statement are or is true regarding calcium 2 plus? Okay. Z means, remember, that is the atomic number. Huh? Z is atomic number and zinc 2 plus. I think the wisest thing to do is first we'll write down the electronic configuration states. Calcium 20 we know it goes like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So calcium 2 plus should be 1s2, 2s2, 2p6, 3s2, 3p6. That's where it stops. And zinc, we know 30. Zinc goes like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4s2. We'll write it properly. So zinc 2 plus, we have to remove those 2 electrons from 4s, 1s2, 2s2, 2p6, 3s2, 3p6 and 3d10. Correct? Right. Both ions have 6 electrons each in the outermost p subshell. Outermost p subshell, correct, no people? Correct. That is correct. Because calcium ends up in 3p6, zinc ends up in 3p6. I mean the outermost p sub energy level. Huh? Both ions have 18 electrons in the outermost shell. Do you agree with that? Do you agree with that? Yes or no? No, that is wrong. That is wrong. Because in the outermost shell, when they say outermost shell, they are talking about outermost main energy level. Calcium has how many? The outermost energy level, it has 8 electrons. Zinc has 18 electrons. So for calcium it is 8 electrons, but for zinc it is 18. Therefore they are definitely not equal. Calcium 2 plus ion has 8 electrons in the outermost shell, and zinc 2 plus ions has 18 electrons in the outermost shell. Yes, that's correct. Both ions have 8 electrons each in the outermost shell. Ayyo, that's wrong. Boring question, people. They are, they are talking about the same thing in B, C and D. What is the answer for this question then? 27th one. Yeah, A and C are correct. They are asking for the true statements. A and C are correct. A and C, not A and B. If A and C are correct, what is the answer? It's an option which we do not have in any of those first 4. It is the 5th answer. It is the 5th answer. Okay. So for people who cannot remember the combinations, that will be given to you in the question of AB correct. AB correct is first answer. BC correct is second answer. CD correct is third answer. AD correct is fourth answer. All the other combinations, 5th answer. So here A and C it's not within the first 4 combinations, no? That's why 5th answer. And why 5th answer? Because AC correct. All right. Done. Right, is that all we were supposed to try? Yes, that's all we were supposed to try. And here we have included those isoelectronic species, last week's theory class. Okay, fine, that's it. So how many questions did we try? I can see 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19. Not bad. 19 MCQs. Right.